All right, hello lovely humans. Welcome back to part 2 of the What is Area series. So in the first part, we learned that finding the area of a shape is really just a counting issue. So we discovered that rectangles pretty much the easiest shape to start with. And so basically, if we create a smaller rectangle within the larger rectangle, you could also do this with tiny little squares if you wanted, but I like to be lazy and use a shape that will allow us to do this quick. So if you create smaller rectangles with a width of 1 and you add them up, the number that you will get will be, you will count B number of smaller rectangles. So if B was 5, in other words, you would add up 5 of these rectangles, and then that would tell you the area, which of a rectangle is just the height, A, times the width, B. And it's just because we're counting up that number of times. So let's apply this concept to learning about and actually building up to the area of first a parallelogram and then a trapezoid. Okay, so parallelograms. I'll try to draw this carefully. Okay, so there are a couple of special properties of parallelograms that we have to acknowledge before we get started. So I'm going to label the sides A, B, C, and D, because whenever we are trying to understand something new, it helps to be able to think about it in a broad way. So that way, whatever parallelogram is thrown at us in life or on a test, maybe you have a farm that you're trying to figure out how many crops you can put in there. And so you have to figure out the area of the space so that you can put as much in there as possible. Or maybe you have to solve this on a test. There are lots of different applications, some in real life and some in school. They're all important. But you're going to get different types of shapes, right? So my job is to help you see that whatever parallelogram you get, you can handle. So on any parallelogram, there are a couple of special properties, and one of them being that these two lines are parallel. A is parallel to C, and B is parallel to D. That just means like two roads that continue in the same direction, they'll never intersect. That's not terribly important for what we're doing, but it is important to acknowledge because it helps us solve some problems with parallelograms. But what I really want to focus on is that in a parallelogram, another special property is that opposite sides are equal in length. So that basically means that A and C are the same length. That's a funny looking C. Let me try and draw that again. And B and D are the same length. So we actually only have two different lengths in this shape. So that makes it a little bit easier. Okay, so area is just counting. Pretty rad, right? So in that case, the first thing that I notice with a parallelogram is that I can divide it into shapes that allow me to count and add up those different shapes. So I can create two right triangles inside of this parallelogram. And that also gives me a nice rectangle on the inside. Okay, so now we have to start asking, what the heck are the lengths of the sides of the triangle? Because the idea is that to find the total area, we're going to add the area of this triangle, the area of that triangle, and the area of the square, and that will equal the parallelogram. So to write that in an equation, I'll just do a triangle plus a triangle 2, I'll say that was 1, plus a square, or rectangle. It's probably not a square. It might be, who knows? We'll figure that out. Okay, so this is the equation that we are going for. So the first thing is to ask, well, what the heck is this triangle? I have, I'll draw it over here. We'll draw it bigger. Okay, I have a triangle, and at some point I'll draw it correctly. So I have a triangle here with length A, and for now, since I don't know what these lengths are, I'm just gonna call this X and Y. Actually, let's flip that for purposes that we will get to later. So this is going to be X and this is going to be Y. So now I'll label it here. I'll say that this is X and this is Y. Okay. And then this second triangle that is all upside down. Let me try and draw that appropriately. That's a little wonky, but that's fine. So I start to label this C, and then I'm like, wait a second. I know that A and C are the same. Rad. So this is A. And if I have the same triangle here, well, I guess what I should say is that because A and C are equal, I actually know, therefore, that this also has to be X and this has to be Y. And it helps when you look at it because you can see that, okay, if I drew this to scale and I took a ruler here, I could find that this and this were the same length. So in this case, this is X and this is Y. So that's nice because now all of a sudden, the area of our parallelogram we already have. We know that the area of one triangle is 1/2 base times height. So that's going to be 1/2 X times Y plus 1/2 X times Y. And we still have the area of the rectangle in the inside that we're trying to figure out. So in that case, we need to find this distance right here. Well, what is that distance? Okay, so the whole bottom of our parallelogram we call D. But this chunk right here is X. And so this distance is going to be D minus X. Just like if we had a length of 10 here, and this was 3, and we wanted to find the difference, we would say, well, 10 minus 3 is 7. And so this would be a length of 7. But to keep this generic, because I don't know how big your farm is or how big your parallelogram on your test is going to be, we'll keep this generic. Okay, so that's pretty radical though, because now all of a sudden we know the base of our rectangle and the height of our rectangle, which is just Y. So now we can say, aha, we add together the area of the rectangle, which would be D minus X times Y. Boom. Okay, and now all we have to do is simplify this equation right here. So the first thing that you will notice is that 1/2 plus 1/2 is just 1. Cool. So the area of our parallelogram is 1/2 X times Y plus 1/2 X times Y. Because these two are the same, I can smush them together and I get X times Y plus, well, what's this? I need to simplify this out. And so I'm going to write this out here. So D minus X times Y, we need to distribute that. So we get D times Y and a negative X times Y. Okay, so then I add plus dy minus, well actually, okay. I'm going to scoot this equation over because I'm running out of room. So we get the area of a parallelogram equals X times Y plus D times Y. I'll put a little multiplication in there and I'll fix that plus sign. And minus X times Y. Ho-ho! This is interesting. Because check this out. I have a, whoops, oh, my chalk broke, so sad. I have a negative X times Y and a positive X times Y. Oh, what's up? They cancel! Huzzah! Pretty rad. Okay, so now all I have left is D times Y. That's it. Where Y is the height of this triangle. So oftentimes you'll see Y labeled as H but it really doesn't matter. These letters are just variables. They're placeholders for whatever actual numbers you have. So to find the area of a parallelogram, you would need to know that value. What happens if you don't know the height of the inside? Well, that's when you start getting a little creative, and that's when the parallel lines comes into play, because you can use trigonometry, or sine and cosine and tangent, to actually find this, because you know that these two angles are the same. Typically, when you have a parallelogram, you are given on a test or something, you're probably given either the height or the base, and if your teacher wants to be real tricky, they'll probably give you the angle of one of these sides, and then you have to use either sine, cosine, or tangent to find the height of this triangle. But you are competent and you can totally do that. So just remember, SOHCAHTOA, so sine of an angle is opposite over adjacent, or sorry, opposite over hypotenuse. This is why I have to write this down too. Etc. Cosine is adjacent over hypotenuse, so that means the sine of this angle is going to be y over a. The cosine of this angle is x over a, and tangent is SOHCAHTOA. That's an A. My goodness. So tangent is opposite over adjacent. And so if you know the angle, so then you can solve for whichever side you need. Pretty cool, right? Okay, so that's a parallelogram. We're already past 10 minutes, so I'm actually going to break this into 4 parts now. So in the next part, I will cover a trapezoid. And that means if you're comfortable with this and you're like, cool, I don't need to see the trapezoid, I want to move on to the calculus stuff, awesome. And if you're like, I don't know, this is kind of confusing, this is a lot of letters, don't worry, I got you. Let's talk about trapezoids, we'll do another example, and that way it'll start to sink in. And I would also encourage you to work through this on your own, put some numbers here, and challenge yourself to do the same thing that I did, and basically figure out what this equation is. All right, so if you want some more examples, check out the next part. All right.